4 is one of these horrible quadratics where it doesn't look like a quadratic yet, but we can turn it into a quadratic using a substitution. And even though it looks weird, because we've got a half and a quarter, this term here, the middle term here, is always like our x term. And the first term is always going to be our x squared term. I've never seen a question where you have to rearrange it first. So we're going to want this to be our x, and we're going to want this to be our x squared. And if we do that, if I set this to be x, so y to the quarter is equal to x, will y to the half be x squared? Well, let's check. If we square both sides, we obviously do get x squared, but is this the same as y to the half? And yes, it is, because if we've got brackets and powers, then we're going to times these together. So that will give me 2 quarters, which is a half. So that's fine, that's what we want. So we've got the x squared is equal to y to the half, and y to the quarter is x. So we can now write down our equation 2x squared take away 7x plus 3 equals 0. And again, this should factorise with a 2x and an x. It's going to have to be a 3 and a 1, and because I'm making a 7, it's going to be good to have the 3 here. So we've got 6 x's and then 1 more there. They've both got to be negative because we're making negative 7 x's and plus 3 at the end. So x is therefore either equal to a half or x is equal to 3. But we're not actually bothered about what x is equal to. We made up x. We actually want what y is equal to. So if x is equal to these two numbers, then that's what y to the quarter is actually equal to. Y to the quarter is the 4th root. So if I want to undo that to work out what y equals, I'm going to have to raise these to the power of 4. So a half to the power of 4 is a half times a half times a half times a half, which will be a 16th. And 3 to the power of 4 is going to be 9 nines, which is 81.